guys, welcome to another lab flip video. This is your potential and kinetic energy lab that you'll be doing next week. So as usual, you need to watch this video and at the end of it, go take the quiz until you get 100 on it. This lab has 4 stations. There's a lot of movable, bouncy parts, so part of your responsibility is going to be to not be letting balls bounce all over the classroom, controlling your equipment. It's an important job as a scientist. This first station, you're going to be following the instructions as we've done in the past. We have a check mark where you will be checking off each step as you do it. That way your data should be good because you don't skip any steps. This one just involves dropping a ball from the mark. It tells you to start with 50. So one person will drop the ball. The other person's job is to look how far up it bounces on the first bounce. That's all you need to keep track of is the first bounce, because you know these guys will keep bouncing if you let them go. So we drop it, observe it, and then collect it. And you will do that 2 more times. So you're going to collect 3 pieces of data at that height. Then you'll do it again from 75. Then you'll do it again from 100, which is the top of the meter stick. Okay? Make sure you're writing down your data, and then any averages or anything, the averages will be done after you're done. So your job while at the station will be to collect data. You can always do the math later if you need to. All right, second is the bucket of sand. This time we're going to be looking at if it makes a difference how much mass an object has. So you're going to have a golf ball and a ping pong ball. And again, I'm going to move this bucket over here a little bit. You're going to drop them from a meter, which means from the top of the stick. So you're going to drop the golf ball, and then you're going to drop the ping pong ball, and you're going to look to see how much of a dent. Ping pong ball made a little bit of a mark. Golf ball, wow, quite a difference. So that's what you're going to be looking for, and you're going to be drawing what you see both from the top and from the side, which is why we're using these clear buckets. Okay? That is station 2. Again, let's keep the balls in the station area and not let them roll all over the classroom. And you can see here, we've given you a space to draw what you see. Then we're going to move over to station 3. This involves a jar of sand, a computer, and this is a thermometer. This is called a vernier probe. This one happens to be a temperature probe. So again, you're following your steps, checking them off as you go. But basically you want to take the temperature. You do that by putting the thermometer in the sand. And then on the computer, there is a green little arrow that says collect. And that's what you click on. And you can see it's collecting data every half a second and putting it on the chart. And the instructions will tell you how long to let it in there. And then you hit stop, and here's your temperature right here. And this is what you're going to write down on your data sheet. And you're going to take the temperature before. Then you're going to take the thermometer out. You're going to put the lid on the jar. You're going to shake it for 3 minutes. So you've got a timer here. And it needs to be shaken the entire time. So if you need to take turns, swap it back and forth, but shake it for 3 minutes. At the end of 3 minutes, you're going to take the lid off, and you're going to take the temperature again. Same thing, hit the collect button, hit the stop button, and whatever your temperature is, look in just that little bit of time it went up. So we'll see if yours does that or not. That's the goal. We want to see if motion has anything to do with the energy. And then the final stage is more like a review than lab equipment. You're going to have some drawings of situations where there's potential and kinetic energy, and you're going to use these little cards here to label them. Like here, this has more kinetic energy than potential. Let me see. Maximum potential energy, there we go. So you're going to put the labels on, get your teacher to check them, and then you're going to copy a couple of the drawings onto your lab sheet, and then you're going to have questions to answer. So that's all there is to it. It's a fairly straightforward lab. We should be able to do it in class and finish up all our write-up that day. So now you know what you need to do. Go take the quiz, take it till you get a 100, and be ready to be safe and have fun in class.